Okay, so good evening all again. So I am Lalit Bharti and this is the NPTEL live session of week 2. So we will be following the course. So the plan is we will start from the refreshing and revising the course content first in the first 1 hour, and later on in the second hour we will be discussing some problems, some assignment problems, and some other relevant problems. So which can be come in your NPTEL exam and which will be helpful to cover your all course content. So this is your week 2. Again, I am Lalit Bharti. I am a PMRF fellow in the Department of Physics at IIT Kharagpur. And these are your week 2 content. So basically in the NPTEL lectures, in week 2, these 3 broad topics were covered. First is the non-conventional source of energy. So basically in this chapter, all the non-conventional sources of energy were discussed, like geothermal, like solar, like wind. So these are basically the beyond conventional sources of energy. Then in the second chapter or in the second topic, the energy consumption was discussed, the overall energy consumption and which sectors, and it was divided into sectors, which sector is more energy consumer compared to other sectors, and all other things were discussed in the details. So we will go and we will have some problems in this section also. And third section is the details of energy usage in each sector. So here it was divided into sectors, and these things were discussed. So basically, we were starting from the world energy uses. So we are more interested in overall the world energy uses, how this energy is produced. So basically, till now, all the energy used by humans, these are the 87% is produced from the fossil fuels. So here you can see this data has been taken from Wikipedia. So here you can see the uh, the contribution of coal is around 30%. The contribution of oil is 33%. Natural gases are 24%, and other are 2%. With nuclear 4%, following hydro 7%. So basically, all these terms, these are the fossil fuel based energy sources, and only this hydro and other fuel, they can be they can come into either the renewable or the non-conventional energy sources. So here we can see the most of the energy we consume or which is being produced by the fossil fuels or the conventional energy sources. Here again we see again the word energy uses, as it was mentioned also, the humanity consumes around 800 exajoules of energy. So these in the terms of exajoules. So exajoules are basically 10 to the power 18. Exa is the 10 to the power 18. So uh, this is the amount of energy estimated, and this is again the division of energy and depending upon the way of they are produced. So renewable again is only 19%, and rest of the energy is the conventional energy sources. So in the renewable also they have divided. So in the renewable, most of the energy is produced by the biomass, 53%, 23% the hydropower. Hydropower are basically all the dams comes into this kind of hydropower. 15% is the bioheat, and rest are in very smaller portion. So these are biodiesel, solar photovoltaics, wind, biopower, solar heating, geothermal, etc. So although these trends are now changing and solar photovoltaics are now increasing, but still in compared to biomass, the hydropower, these are still in very few percentage. So we will mainly discuss on the renewable part of energy. We will discuss various types of renewable energy sources, and then we'll go for the assignment questions. So we will first in the renewable energy sources, we will first discuss the biomass. So this is a renewable energy source. So this can be the first kind of renewable energy source. So this is basically biomass is basically the organic material, whichever or whatever we see in the environment, the organic things that can be referred to biomass, and which comes from the living organisms like plants, animals. So these materials are called biomass, and usually the energy is produced by burning the biomass. So it can be wood, it can be crops, agriculture residues, like the which is produced side side by side in the agriculture, the vegetable oils, and which include animal fats, these garbage, which the organic garbage we used to throw, we and the sewage produced from humans, and the animal manure. So these all comes in the biomass category. So this is kind of the oldest renewable, the oldest. This is kind of the oldest. We can say this is the oldest renewable energy source because from decades or from very a long time, from very early time of humanity, we are using this biomass as renewable energy sources. So we are burning the woods, and we are using animal manures like cow dungs. We are using various kind of vegetable oils, various kind of uh, animal fats. So from early humanity, we are using this biomass as the as a uh, very much available energy source. Similarly, the second renewable energy source is the hydropower. So hydropower is basically energy generated with the help of water. So you can see three examples here. First one is the impoundment type of hydropower generation. This is usually what we regularly see in India and in many in almost all the countries. So this kind of hydropower source energy generations are these are based on some dam which can be on the bank of some river or some water reservoir. So basically, we have a water reservoir. Then we use this water, which the reservoir is situated at some height. So we use the potential energy of the water, potential energy, which comes from the gravity. We use this energy to drive the turbine. So basically, there is a penstock. Penstock is the way which through the water comes in from the height, and its potential energy becomes turns into the kinetic energy, and this kinetic energy is used to move the turbine. So as the turbine is rotated, this turbine is attached with some energy generators. So these generators generates energy, and this supply to the transmission lines. Okay, so and the outflow, the water after the rotation of turbines, the waters come out through this outflow. So this is a very much used way of generating power or generating energy through the help of water. So this is a main type of hydropower generation. The main disadvantage of this hydropower, this empowerment type of hydropower is the social impact, because whenever you build a dam, it impacts the or local agriculture, local society, local immunity, and the local environment. So first, you need to build a large uh, build a large dam. You need to stop the water, so all the marine life will be affected. So just to improve the marine life, or just to mitigate from the adverse effects of this dam construction, so few things can be done, like fish waste can be made. This is a solution for marine life, because this kind of construction of this kind of dams will affect the ecosystem, the marine ecosystem, as well as the flora and faunas nearby. So this fish waste can be used by the fish which are migrating from one place to another place, and it will provide them a pathway. So the second kind of these are large hydro stations or large hydropower, which can be from 100 megawatt to 10 gigawatt, depending upon the size of dam, the size of reservoir, and number of uh, turbines, generators, etc. The second kind of hydropower is the diversion type of hydropower. So basically, it can be a smaller hydro station which can be up to around 30 megawatt. So they just use a smaller reservoir at some height. These are basically man-made structures. So they just take water from some source, like some river, by diverging and by making a channel. So through this channel, They fill the reservoir, and after it, they use through the penstock, again the similar to the impoundment type of hydropower. They use this penstock and use this water to generate electricity through generators. And again, as the outflow, they just diverge the remaining water in the river. So this is a divergent type of hydropower. The third and interesting one is the pump storage. So basically, this is completely man-made. We just need a reservoir at a normal height, or you can say two reservoirs, one at height h and one at height smaller h, where h is larger than small h. So then, when we have the additional or we have the extra energy or extra power, we can use this electricity to pump the water content at the certain height, at the height edge. So the water will be first using by motor or pumps. First through pump, it will be reaching from height h to h. Then whenever the energy is required, the valves will be opened and the water will flow from height h to smaller h. So it will provide energy by rotating the turbines. So through this method, whenever the energy is required, you can just release the valves and the flowing water from upper height to lower height, they will provide you, they will just rotate the turbines and the generators and provide you energy whenever you need. And when the energy in the excess, you can pump it back the water from the lower reservoir to higher reservoir. So these work as a energy storage. So this is a kind of large scale energy storage device. So this is all about hydropower. The next is wind energy. So wind energy is quite known technology nowadays. So basically these are used to produce energy through wind currents. So at the left side, that is a typical construction construction of a windmill. So where it have rotor blades. Rotor blades are made in such a shape aerodynamically that whenever the wind hits the blades, they rotate in a particular direction. So when they rotate, they also rotate the attached generator with them through the gearbox, which controls the speed of rotation. And whenever required, there can be a braking mechanism also. So whenever required, they can slow down the blades. So any kind of destruction will be the windmill will be saved from any kind of destructions. So the generator will produce energy in form of electricity. Then it will be transferred to a transformer and then through the grids, it will be provided to consumers. So these are some kind of offshore and onshore wind turbines. Onshore is basically based on this is on normal ground, where offshore is at the sea level. So because the wind energy depends on the wind speeds. The speed of wind. So wherever the wind is flowing at high velocities or high speed, the uh, generated wind energy will be higher in amount. So that's why this kind of wind turbines are placed on the when at the places where wind flow or the wind currents are very high. So if you know, these are basically onshore wind turbines are mostly placed on the hills and valleys. So these hills and valleys where the pressure is produced and the turbines faces high wind currents. High wind currents. So due to these high currents, like if you see the structure of valleys, this current will pass through a smaller portion. So from the laws of fluid dynamics, you can understand if some fluid is flowing through a larger intersection to a smaller intersection, the velocity will become higher. So if this is A1 and this is A2, if A1 is higher than A2, then if the wind speed is at 1 V1 here and V2, so this V2 will be higher than V1. So through this method, we can understand the reason of placing the wind turbines at hills and valleys. And similarly, on onshore, because here the wind currents are very uniform and high compared to the normal ground level, because there's no destruction, there's only sea. So on the sea level, the currents are pretty much high and there's no humidity living there. So they can be made up to the higher heights, and the larger wind turbines can be placed, which will be producing higher amount of capacity. So you can see in onshore, the capacity mentioned is 5.5 megawatt with one turbine, where in offshore there is 17 megawatt from one turbine. So this is all about wind energy. Now solar energy, we are all already very familiar with the solar power. So the solar power is basically all this depends on the radiation from the sun. So if this is the sun, so whatever radiation we get from the sun, so it converted from solar to electrical energy or thermal energy. So here's the first one is the typical example of a solar panel. This is a solar panel which converts solar energy to electrical energy, and we can convert this and this electrical DC currents in DC, and we can store this in batteries. Otherwise, we can convert this to AC, and we can run all the home appliances we have. So this is a home level, or similarly, we can have the smaller solar energy devices which can used as mobile devices, which can be used to charge your mobile phones and other smaller applications. So this is basically a household solar panel. Here at the right side, you can see this is a solar heater. So this is also place that you might have seen in the solar heater at the rooftop of some houses. So it basically use the solar power, and it just convert in the thermal power. So the solar power will be incident on these glass tubes where the water is flowed, and in getting this solar energy, the temperature of water will increase, and it will either pumped out to the uh, to a reservoir or a hot water tank. And as we know that hot water remains at the top of the cold water due to the density. Density of hot water is lower than density of cold water. The cold water will be at the bottom, and through this channel, the cold water will again come through the solar collector. So in this circular motion, the water will absorb the solar irradiance, and it will get warm up. So which will be then used as in houses. So these two are household applications, where the the third image is the industrial level or the large scale. This large scale solar power generator unit. So here basically these are heliostats. Heliostats are basically the kind of mirrors which reflects the solar spectrum or the solar energy, reflects to a receiver. So receiver gets heated up, and receiver have some fluids which can be ionic fluids or some molten salts. Mostly the molten salts are used in the receiver. So through these molten salts, they will circulate through the circulate this energy to the steam generator, and this steam generator will generate steam which will be used to drive the turbine blades. And after the turbine blades, it will be attached from with the generator, and generator will produce electrical energy which will be then provided to power grids for further uses. Then this steam will be cooled down in this condenser, and it will again uh, uh, feed it back to the steam generator. And during that, the temperature of molten salts will decrease, and they will again go to the receiver. So through this whole process, The solar energy is converted first to the thermal energy, in which produces steam, and then the thermal energy produce electrical energy. So these are example of solar energy generated. So in the renewable energy, one interesting topic is geothermal energy. So geothermal energy depends on the availability of steams or hot water streams below the earth. So wherever this kind of hot streams are available, the difference of temperature the energy will be produced with this difference of temperature. So wherever the high temperature water is available or the steam is available, it will be used to produce steam, and this steam will use to again in the similar fashion it will drive the turbine, and turbines will drive the generators which will produce electrical energy or electricity. And the when after the steam, after generation of electricity, when the stream is getting cold, it again pump down to the earth again inside the ground. So the second schematic is the same thing. First there is a turbine, this production of steam, and then the injection back of steam in the ground. And in between we have turbine, a generator which produce power. The next topic is ocean energy. So ocean energy is also a kind of is a type of renewable energy which can be of two types. First one is the ocean thermal energy conversion, and second is the waves and tidal. So the first one, the schematic is shown for the first one. So this is ocean thermal energy conversion. So due to the thermal, it depends on the temperature gradient or the difference in temperature. So at the sea level, the water gets warmed up due to the sun. Due to the sun rays, this solar energy is absorbed by the water, and this water gets warmed up. So we can see the surface temperature is around 25 degrees Celsius up to 10 to 20 meters. Where when we go deep inside the sea, we will see the temperatures can go up to 5 degrees Celsius. So we use this temperature difference. So basically there's one warm surface sea water. There's a pump which will go inside the evaporator. So evaporator will drive the turbine. So after because here kind of ammonia pump is used. So ammonia is used as a similar opposite manner of a refrigerant. So here by getting energy by thermal energy from the warm water, the ammonia gets evaporate. It gets into steam, and it drive the turbine. After the turbine is attached with the generator which produce an electricity. And in this process, the ammonia get cooled down. Ammonia steam get cooled down, And after the condensation happens with the help of the cold seawater, and it again become liquid. So these cycles runs in continuation, and we get electricity by this temperature gradient. So this is the first type. This is the ocean thermal type of energy. Second is the and tides. Wave and tides. So basically, from the oscillating water columns, you use this physical energy or this mechanical energy to compress air and drive turbines. And similarly, the tidal barrages. So they are located on specialized dams. So they use the tides, and when the water level or sea level increases at high tide, they store some water, and during the low tide, they use that water at a higher altitude to drive some turbines. So these are mechanical type of energy conversion or energy production, and these is first one is the ocean thermal type of energy production. So this is ocean energy. The next, so now we will start the assignment questions or the questions from previous quizzes. So in this 1 hour, we will be discussing all these questions and the uh, fundamentals behind. So through these questions, we will also cover almost all the syllabus of week 2. So I'll be taking a 5-minute break, and after that, we'll resume the class and we'll start the question discussion. Okay. So now we will be discussing these questions. Okay. So the first question is states that biomass constitutes a significant fraction of renewable energy sources or resources. So as we also already discussed, biomass is basically the oldest renewable energy source we are using. And here you can see the distribution of energy consumption. And in the renewable section, the biomass consists for around 43%. So it includes the bio-waste, the biofuels, and the wood. So yes, we can say their biomass is in the significant amount as compared to other renewable energy resources in this renewable domain. So basically, you can say yes, this is true. So we'll go up to for the second question. So these are the non-graded assignments of previous year and this year. So the second question is per capita energy usage is approximately the same internationally. So the per capita energy usage is the for a country the overall energy uses, total energy uses by a country divided by the population of that country. So it can be multiplied by 1000. So basically, the per capita energy usage is the energy consumption or energy use per 1000 people in that country. So it is the normalized energy uses. So as we know that each country is not uh, contributing equally in this energy use, and from this image also we can see that the more brighter means more energy consumption per capita. So you can see Canada, Iceland, these kind of countries, United States, these are high in energy consumption. Whereas India, many African countries, these are lower in energy consumption. So due to the higher population of China, although China is very high in energy consumption, but it when it comes in terms of the energy per capita users, then due to the high population of China and similarly India, the energy per capita energy consumption or energy usage that goes down. So here we can see that per capita energy consumption is not same for all the countries. So we can say that this statement is not correct. This is false statement. So now with this example, we got to know that what is energy, what is per capita energy uses, and what is the trend internationally. So the third question is the industrial sector uses significant amount of energy for process heating. So the term is process heating. So first we get to know that what is this process heating. So whatever the process in the industry sectors, whatever process which includes heat, it can be using steam, warm water, hot water, or any other hot media which is required or which is produced during the industrial purposes. So whenever the need to be heated up or the heating is included, these processes are process heating. This can be called industrial process heating. And for now, in the current scenario, most of the fuel are used in the process heating are these are mostly conventional. These are conventional resources, not non-conventional. So these are basically these are natural gas, coal, petroleum, and biomass. The uh, biomass can be termed as renewable, but it is very low in percentage. So the mostly used fuels are conventional. So why we are let me admit. Okay. So yes, we will resume back. So basically, this is why we are giving so much focus on industrial process heating. So we can see from this data, almost industry accounts for 25% of EU final energy demand of the total industry demand. The process heating consumes 1,920 terawatts hours of energy, which is around 60% of total energy demand. So we can see it is a very huge amount of energy. So we need to take this process heating, industrial process heating in count very seriously. We can see this the 60% of industrial energy consumption or energy demand is comes from the process heating. So this is an example in Indian context. So this is a process heating and share of energy consumption in dairy industry. So basically in dairy industries, there's various processes which are mentioned here. These are various processes, and here is at the y-axis the temperature is mentioned. So that which uh, which process required or which process happened at what temperature. So here we can see only few processes like cooling is at the low temperature and some few other processes. Otherwise, most of the process are up to the more than the room temperature, and few of them requires a lot of energy like sterilization, spray drying, evaporation, pasteurization, and other like cleaning and other processes. So these most of these processes they require a lot of energy and lot of heating. So that is why we need to take care of this industrial process heating. So here we can see that yes, this industrial process heating uses a significant amount of energy. So this statement is true. So this again the question of biomass. The biomass implies burning of wood or organic matter. So we can see as we discussed and as we know that the burning wood comes in the biomass. So we can see that yes, biomass implies to burning of wood or organic matter. So these all are organic matters, organic material. Then these are the quiz questions. Yes. So after this biomass, we have the quiz questions. So first question is GDP of various nation is very closely related to what? So GDP is term for the gross domestic product production. So as we know in the economics point of view, this GDP is a sign of growth of a country. It is basically the economical growth of a country. So here we'll see. So more more a country develops, it needs, and more the growth GDP is, the production of the country increases. So if the production is higher, then we need higher energy. So the energy demand will be higher. So from this statement, yes, if for a nation GDP is related to the energy consumption. So the option first is correct. The second question is, what are the cleaner sources of energy? So as we already know that solar is a cleaner source of energy, wind is a clean source of energy, geothermal, as we discussed, this is geothermal. Geothermal is again a clean source of energy. Similarly, the ocean, this is ocean thermal energy source. This is because it doesn't include any fossil fuels or any other conventional energy. So energy sources. So this is also a clean source of energy. So basically all four are the clean source of energy. So we will move now to the next question. The next question is renewable energy sources are. So as we have discussed this solar, renewable, obviously the solar is a renewable source of energy, solar photovoltaics. Then the biomass is also renewable. So yes, biomass is renewable. But the fossil fuels, these are conventional. Similarly, diesel comes from the petroleum, or it comes from the crude oil. So it is not the renewable energy source, and diesel is also not the renewable energy source. So we can say, okay, answer is biomass and solar photovoltaics. So next question is, we need to match the following. So the first is non-conventional energy, and the other four options are nature of human can renew the energy of time frame. Nature or human can renew the time frame. Availability is unacceptable. Majority of are not using. So we can say that yes, non-conventional energy, most of us, we are not using it till now. And mostly the fossil fuels and the conventional energy sources are used. The second is renewable energy. So from the definition, yes, we can say nature or human can renew the energy in the time frame. Time frame here, the time frame means the human, it can be reflected up to this human life time scale. So at the human life time scale, it can be renewed. So yes, the B can be the first. And similarly, in one as a property, renewable energy is inexhaustible. So these are always available. Inexhaustible means availability. So these are available through through the whole human lifetime scale. So we can say this B comes from, so A goes to first, B goes to second, as well as A goes to third, B goes to second, as well as first. And C now, clean energies begin with the environment, and majority of are using. So since we are till now in the present time, we are not, majority are not using the clean energy. We are still on the conventional. We are still using the conventional energy. So clean energy can be terms to this begins with the environment. So C goes to 4. Okay, so this is the correct order, and these two options are correct. So next question is, advantage of micro dams over large dams are. So the issues with dams are, first the ecological effect. It can be on the marine life. It can be on the flora and fauna. Again, the issues are social, because the construction of large dam needs to move people from the dam side. So if we see the options, the micro dams are basically easy to build. So these are uh, less disruptive. Yes, because these large dams can be called disruptive. So since they include transmission cost and transmission losses. So because micro dams don't need large grids, so they comes with this low transmission cost, as well as because these micro dams are used and power is this electricity is supplied to the nearby areas only, so they comes with low transmission losses. And the last option, infrastructure can be quickly built. So that is also correct. So these three options A, C, and D are correct. So the next question is, we need to match the following. So the wind energy utilize the concept of temperature difference. This is delta T, or we can call this as delta T, affected by seasons, tapped in the form of steam. Photons are the energy packets. So wind energy, it since it affect it's get affected by the seasons, because if this season the wind streams are high, then the generation of energy is higher. If the wind stream or wind currents are lower, wind flows at low speeds, then the wind energy generation is also lower. And the option B, geothermal energy. So from these three options, we can say geothermal energy tapped in the form of steam. So these are steams, or we can call it also hot water which is packed below the earth surface, below earth surfaces, that is used for geothermal energy production. Next, the solar energy. It is clear that solar energy is, because in solar energy, photons or the light is converted, the sunlight is converted into the electricity. So the photons are the source, or these can be called energy packets. So we can say yes, solar in the solar energy, photons are the energy packets. And for the last, ocean energy, as we know, the ocean thermal energy depends on the temperature difference. So it utilizes the temperature difference, concept of temperature difference, and we can say this, that the option B is the correct one. Next question is, the energy tapped from reversible and sources can be stored using, energy tapped from renewable sources can be stored using, so there are four options: batteries, fuel cells, IC, or the internal combustion engines, or nuclear plants. So nuclear plant cannot be the correct answer, because it is not energy storage. Similarly, IC, internal combustion engine, these are not a kind of energy storage. We need to store the energy. These can convert the energy. These are convert. These can convert the energy. Similarly, for fuel cells, fuel cells are basically the devices which can directly use fuel, and it converts it through the fuel cells. They converts it into the electricity. For example, hydrogen fuel cells. Hydrogen fuel cells. So from the hydrogen, we get electricity. But again, these are not storage. So yes, the first option, batteries, are correct. So in batteries, basically the electrical energy get stored, and it can be provided whenever needed. So the the first option is correct. The next question is, an electrochemical device consists of an anode, cathode, and an electrolyte. An electrochemical device consists of an anode, cathode, and electrolyte. An electrolyte can be in the form of solution during its typical function. When attached to an external circuit with metal wires, electrons and ions flow through respectively. So basically, we need to tell that where the electrons will flow and where the ions will flow. So here it is a basic and the schematic or simple diagram of working of battery. This is the working mechanism. So the first one is charging and second one is discharge. So you can see this is the positive electrode, or you can say it is a cathode. This is a negative electrode, or this is an anode. This is the wires. These are the flowing electrons. So here we can see the electrons are flowing through the wires or the external circuit. So in the opposite way of electrons, the ions also move, but the ions move inside the electrolyte from either anode to cathode or cathode to anode. So these are the moving ions. So we can say yes, ions move within electrolyte. So the option will be electrons in the external circuit, ions in electrolyte, correct? Or we can also say electrons in the metal wire and ions in the solution or the electrolyte solution. Right. So these A and first, we can say the first and third option is correct. Okay, so the next question is, it comes from the energy dividation, or you can say the third topic of week 2's lecture. So almost 90% of fuel in the car is used to transport the driver, transport the car, transport the air in the car, or transport the fuel in the car. So clearly the air is not the correct answer because air is very light in mass. Second is this driver. So driver is around, can be around 17 kgs, where the fuel transport in the car. So if this is a typical car, so if this is a typical car, the fuel is around 30 to 40 liters. So the mass is similar, around 30 to 40 liters, or we can, if we consider 1 kg as equal to 1 liter, then it is around similar in kg. And the mass of, or the weight of the car itself, it comes around 1 ton, or 1000, around 1000 kg. So here we can see that yes, 90% of the fuel is used just to move the car, which is real. The car itself is 90% of the overall weight, including driver and the fuel. So yes, that we can say the 90% of fuel in the car is used to transport the car itself. Yes. So the next question is, so the next question is the fuel to ratio defined how a fuel is burned. So we basically need to consider about burning of fuel. So this schematic just explains how a fuel is getting burned. So fuel are basically hydrocarbons made up of carbon and hydrogen. And oxygen is, so so it can be, for the example, this is methane. So in the process of burning, the methane or these hydrocarbons, the fuel is first mixed with this oxygen. These are getting mixed. So this is an example of combustion or internal combustion in an engine, and overall burning of the fuel is always similar. So first they interact, this fuel interact with the oxygen. And after the mixing, they just need to get a spark. After the spark, they burn and produce a lot of energy. Or we can just say that this is energy. It produces high temperature, and the product are H2O and CO2. So here we can see that each atom of carbon, so carbon will give the one atom of each molecule of hydrocarbon will give you one molecule of CO2. So the carbon and the oxygen, so these one molecule or two oxygen atoms, they will give you one molecule of CO2, and remaining will be H2. So here the ratio of C and O is very important. The oxygen comes from the air. So here we can say the fuel to air ratio defines how cleanly the fuel is burned. Cleanly means all the fuel is burned and there's no excess fuel which is unburned. So no unburned fuel is remaining. So we can say it is clearly burned. So the statement is correct, as fuel to air ratio defines how clearly fuel is burned. So these were all the questions we had. So here in summary, we can say we have just revised the concepts of week 2. So it includes various sources, various non-conventional energy sources, and the energy consumption was discussed sector-wise by humanity. Humanity means the per capita. So we were just shown how the per capita energy consumption is calculated and what is the trend internationally. International trend. So, and we had questions regarding the topic. So this was the summary for week 2. So if anyone have any doubts or any wants to discuss about anything, so we had 50 minutes left, and we will be discussing about any relevant topic. So if anyone wants to discuss, they can unmute or you can just type your query in the chat box. So I will get back to you and I will just solve your queries. So the class will end at 9. Till that, I am here to solve your any questions regarding your assignment, regarding your previous quizzes, or any other queries. Okay, so here we will be ending this session and we will start. The next session will be on the next week at the same time, and we will start with the content of week 3 in week 3 class lectures. So again, the same. We will revise the concepts of week 3 and we will do some problems from the week 3 content. So we ended this session here. Thank you.